Hello, my name is Luciana Paz and welcome to a Patran tutorial. This is workshop 8, various methods of solid meshing. First thing we're going to do is create a new file and we're going to save it on the same folder you opened Patran. We will click OK. You have to make sure that the tolerance is on base mode. Next we will import a pair of solid files. So we'll go to File, Import, and we will select logx.empty and we will click Apply. Then we will click OK. I recommend that you use ISOView 1 to display the model. We will click on Group, Modify. We will rename the solid. We will name the file hex8. We will click Apply and then OK. We will be creating 3 points on a plane. This is the tricky part, so please do pay attention. We will go to Geometry, Action Create Point, and Extract for method. Remember to turn off the auto execute. We will select the two edges that make the outer radius of the solid. Then the back part. We will click Apply. Then we will increase the point size for it to be easier to view. We will do the same with 3 points and we will repeat this process 2 times. Now that we have done this, we will change the action to Edit. The object will be solid and the method will be break. We will select the plate. Remember to turn off the auto execute, and on solid list select the first solid, and on break plane list select the top plane. You can see how it's done in the video. We will do this process 2 times. Now we will be creating another group. We're going to go to File, Group, Create, and we will type the name TED4. We will click Apply. Now we're going to go to Geometry. The action is Transform. The object is solid. And the method is Translate. For the direction vector, the values will be 0, -10, 0. And the solid list will be the one that is shown in the video. Now we will be creating another group. This will be TED10. We're going to go to Group, Create. The new group name is TED10. We will click Apply. Then we will go to Geometry. The action will be Transform. The solid Translate. The direction vector will be 15, -10, and 0. The solid list will be the 4 solids. We will then click Apply. We will then be creating a post. We'll go to File, Group, and we'll select Hex8, and then we'll click Apply. Remember to click on Fit View to have a better view of the solid. Now we'll be creating more points. We'll go to Geometry. The action will be Create, Object Point, and Method Extract. the curve list, we'll be selecting 5 edges. This can be as seen on the video. We'll click apply. Now we'll be creating more points. We will go to geometry, create, point, methods, arc center. Remember to turn off auto execute. The points will be 2 edges. We will then click apply. We'll be creating planes. Therefore, we'll change the object to plane. Turn off auto execute and select the points that we want on the plane. This process will be done twice, so do follow along to the video. Now we'll break the solids. On geometry, we will change the action to edit. The job will be solid and the method will be break. Turn off auto execute and the solid list will be solid 6, which is the one we have selected, and the break plane list will be the plane 3, the one that has just been selected. This process will be done 2 times, so please do follow along to the video. Now we're creating the last point on our plane. We will have to create object point and method project. Turn off auto execute, and on the point list, select the points that are being selected on the video. Once a point is done, do change the object to plane and select the 3 points that are being chosen on the video. We're going to break the solid. Therefore, the action will be edit, object, solid, and the method is break. The plane is selected, and on the solid list, we will select that are being shown on the video. For the pop-up, just click yes for all. Now we're going to delete the solids and the planes. On geometry, action, we'll click on delete, object, solid. We will select the solids on top. In this video, there are 4 and 5. We will click apply. For the plane, we will change the object and select plane. We will select all the planes on the solid. We will then click apply. We will repeat the solids. Geometry. The action will be edit. The object will be solid. And the method will be break. Repeat. Remember to uncheck the auto execute. We will select the 5 solids and then click apply. Go to home and click for the L that displays the solid labels. Now we will mirror the solid. We'll go to geometry. The action will be transformed. The object is solid and the method is mirror. On the define mirror plane normal, we will delete what it comes up first, and we will select the one that has 3 points on the plane. Make sure to select the 3 points that the line is on the plane. And the solid selection will be all the solids. Then click apply. We are creating more groups. We're going to File, Group, Create. The group name will be Hex 20. We will click Apply. Next we will go to Geometry. The action is Transform. The object is solid. Method Translate. The direction vector will be 15, 0, 0. And the solid list will be all 10 solids. We click Apply. Now we're going to File, Group, Post. On Group Post, we will select all the groups and we will click on Apply. Now we can see the 4 groups displayed. Now we will create a coordinate system. We're going to go to Geometry. The action is Create. The object is, and the method is 3 points. Remember to turn off Auto Execute. Select the points that are being shown. Now we're going to go to Group, Post, and select the Hex 8 group only, and then click OK and Cancel. And we're going to go to Mesh. We will create the action. The action will be Create, the object Mesh, and the type Solid. Remember the method in the measure is isomesh and the topology is x8. For solid, select the hex 8 geometry as shown on the video. We will then click Apply. This process will be repeated for the hex 20. For the TET4, we're going to Group, Post, and select the TET4 group. We will create a mesh, but this time the topology will be TET4. The solid input list will be the one that has been shown, and we'll click Assemble Parameters, and for the Assemble Parameters, we will make sure that the mesh by solid 4 faces is checked, and we're going to select the entire, and then we'll click Apply. For TET10, will be the same process, but instead of choosing TET4, we will be choosing TET10. Now we will see the 4 groups. We're going to go to Groups, Post, select all the groups, Apply, and Cancel. We're going to create another mesh. This will be to verify that everything is okay. The action will be Verify, Object, Element, and Test Boundaries. Then we click Apply. We will change the action to equivalence and the method tolerance Q. Then we will click Apply. We will return to Verify and click Apply. To do analysis, we will copy a coordinate system on all 4 groups. Therefore, we're going to Geometry, Transform, the action is Transform, the object will be chord, and the method is Translate. The direction vector will be 15, 0, and 0. And the coordinate frame list will be called 1. Follow the process on the video for the rest of the coordinates. Now, we'll be creating fields for the loads, BCS. Go to Home and click on the smooth shaded icon to have a better view. Now we will go to Loads, BCS, and on the Fields section, we will create a special and the method will be PCL function. The file name will be the one that is shown on the video. The coordinate system, do make sure that it says chord 1 and the color function will be the one shown on the video. Do click Apply. This has to be done for the 4 groups, therefore do follow along to the process on the video. Now we will be going to Loads BCS. The action will be Create, the object Pressure, and the type Element Uniform. The new set name will be Hex 8 and the input data will be, we'll type 1000 and the pressure will be the one for Hex 8. You have to repeat this process for the 4 groups. On Application Region, we will be selecting the one that is shown on the video. This one applies for both hexes. For a TET one, it is different. Please do pay attention. We click Add, and then Apply. Now we will be doing the same for hex 20. We click Add, OK, and then Apply. Repeating the process, we select, we add, OK, Apply. Now we're doing the same for TED 20. I'm sorry, TED 10. Select region. Apply. We'll be selecting, add, OK, and then apply. We select all, apply. We go to home, click cancel. Now we'll be creating a displacement load. The action will be create, the object is displacement, and the type nodal. For the new set name, we will use constraint. The input data, our translations will be 0, 0, 0. Click OK. On select application region, we will select the surface or face icon. We will select the back part of all 4 models as shown on the video. We click Add, OK, and Apply. We will be defining the material. We go to Properties, we click on Isotropic. Our material will be aluminum. Input Properties, please insert the ones as shown on the video. We will click OK and Apply. On Properties, we will select the one that says 3D Solid. On Property Set Name, type Solid. The input property will be the material that we just created. which is aluminum. We will select and then click OK. For the application region, we will select all the solids, click Add, then Apply. We will check that the loads are okay. We're going to Loads, BCS. In the section of Load Cases, the action will be modified. We click on Default on the pop-up window. We will then click Cancel. We will now be creating an analysis. Click on Analysis. Go to Solution tab. Check that linear static has been selected. We will click Cancel, and then we will click Apply. This will create an XDB file. Once generated, check on the XDB file. Select Results File, and you will choose the XDB file that has been created, and then click Apply. We will be going to the Results tab. On the Results tab, the applicable B deformation. The selection deformation will be Displacements Translational. We will go to Display. We will uncheck the Show Under Form and then click Apply. We will go to click on Plot Erase icon and erase on the geometry and click OK. In Results, we're going to create. The object will be Fringe. For Select Fringe Results, search for Stress Tensor. Click Apply. This will be the analysis for the group. Thank you for watching.